Swayam Prabha. Digital India. Educated India.
Hello, I welcome you all in this course on refrigeration and air conditioning. Today we will continue with psychrometric processes. Today we will discuss mixing of air stream, summer air conditioning, hot and humid outside when the weather is hot and humid outside, summer air conditioning when the weather is hot and dry outside, single cooling coil and mixing, single cooling coil and bypass mixing. The mixing of return air with the fresh air. This mixing is mixing of return air with the fresh air. So, first one is mixing of air stream. If there are two air streams, 1 and 2, this is one air stream, another air stream, and they get mixed at one point, and another stream is formed, that is stream 3. Because we are doing this exercise because in air conditioning, we will be frequently mixing the air, return air with the fresh air or return air with the air outside after the coil, cooling coil. So, concepts of the mixing should be very clear in mind before we switch over to the real air conditioning processes. So, if there are two streams, stream 1 and stream 2, and they get mixed and form stream 3, mass flow rate in stream 1 is M1, mass flow rate in stream 2 is M2, and mass flow rate in stream 3 is M3. Now, by law of conservation of mass, we can always write M1 plus M2 is equal to M3. This is an adiabatic mixing of two streams, so there is no heat transfer. M1 plus M2 when their enthalpies are added, then M1 H1 plus M2 H2 is equal to M3 H3. So, enthalpy of stream 1 plus enthalpy of stream 2 is equal to enthalpy of stream 3. One more relation we can draw here, that is W1 H1, sorry, M1 W1 plus M2 W2 is equal to M3 W3. There are three relations which will be governing the mixing of two air streams. Now, W is specific humidity or humidity ratio, W1, W2, W3, specific humidity of stream 1, specific humidity of stream 2 and specific humidity of stream 3. Now, after mixing of a stream, now we can start with summer air conditioning, hot and humid outside, summer air conditioning. Summer air conditioning, hot and humid. Hot and humid means you can take example of any coastal climate. Now, for hot and humid climate, we can take hot and humid climate as, let us take some value for dry bulb temperature, we can take 35 degrees centigrade and humidity may be 70%. That is a typical coastal climate. Dry bulb temperature or outside temperature is 35 degrees centigrade and relative humidity is 70%. Now, inside condition we will maintain this one, 24 degrees centigrade temperature and 50% relative humidity, 24 degrees centigrade dry bulb temperature and 50% relative humidity. Now, we have come from this point 1 to this point 2. We cannot directly come from this point to this point, we have to follow certain psychometric processes. So, here as I discussed earlier also that for such type of situation cooling with dehumidification is done. So, cooling with dehumidification. So, through cooling and dehumidification we can follow this line and then we can come here, and after this at appropriate point the heating can be done and we will be getting this point. So, for this type of arrangement we should have a duct having dampers, filter, then a cooling coil, air is blown over the cooling coil, and after the cooling coil there is a heater, and after the heater the air is sent to the room. So, after the heater air is sent to the room. Direction of flow is this one, and now from the room it will go to the surroundings. So, the process 1, the state 1 will be at the entry of the cooling coil, this is state 1, then this is state 2, this is let us say state 3, this is state 3, this is state 3 we will get at the entry of heating coil, this is a heating coil, and after the heating coil the air will enter the room. So, this is the room supply condition. These coils do have some bypass factor. So, if we take into the consideration bypass factor, in that case suppose here we are getting supply temperature approximately 13 degrees centigrade. Since this coil has bypass factor, so coil temperature is 13 degrees centigrade, bypass factor is 0, we will be getting air at this point at 13 degrees centigrade. Since every coil has certain bypass factor, suppose this coil has a bypass factor of 0.1 or 0.1 or 0.15 any value. In that case, for the purpose of cooling, this temperature of cooling coil shall be less than 13 degrees centigrade. So, the cooling coil temperature has to be maintained somewhere below this depending upon the bypass factor. Higher the bypass factor, lower is going to be this temperature. Suppose we find that the cooling coil temperature has to be 10 degrees centigrade, then this dehumidification will continue up to 10 degrees centigrade, and we can draw this, we can join these 2 points and through a straight line, and this is the process, and we will be getting certain value of temperature which is higher than 13 degrees centigrade. If I depict the process here, this I think on the board it will be clearer to you. This is a psychrometric chart, and this is cooling and dehumidification process. But this process has certain bypass factor. So, instead of cooling up to here, it will get cooled up to here, and from here air will be heated up to the room temperature, right. So, this air which is getting heated in the heater, in ideal case it was a saturated vapor, but here it is not a saturated vapor, it is vapor slightly higher than temperature 13 degrees centigrade, right. Similarly, we can consider bypass factor for heater also. So, heater has to be not only at 24 degrees centigrade, maybe 26 degrees centigrade in order to accommodate the bypass factor. So, this is the air conditioning process for summer where dehumidification and heating is required. Now, another type of climate is the climate where the weather is hot and dry. Outside. Before I start this hot and dry weather, we should understand that what will happen if I mix two streams. Suppose one situation is this, which is very humid, hot and humid air, and there is very cold and humid air. If I mix these two streams, stream A and stream B, let us say in 50-50, I will be somewhere here. Now, what will be the situation of air in this position C? In the position C or state C, a fog will be formed. And the air will become foggy. So, such type of situation may also arise where highly humid, very cold air and highly humid, hot air mixing is there. In that case, we can get the state of fog as well. Now, coming back to summer air conditioning, when the weather is hot and dry outside. Now, hot and dry weather, let us assume outside temperature is 40 degrees centigrade and relative humidity is 10%. This is 10% relative humidity line and outside temperature is 40 degrees centigrade. So, it is a typical desert weather. DBT is 40 degrees centigrade and relative humidity is 10% or 15% or 20%, we can take any value. I mean, this is a typical of hot and dry weather, hot and dry outside. Now, in this situation, best way is in hot and dry weather is whenever there is a low humidity, we can always make use of evaporative cooling process, because evaporative cooling process is low cost process and can be easily attained. Evaporative cooling means we will have to follow the wet bulb temperature line, but here in this case if we follow the wet bulb temperature line, we will not be coming to this state. In this situation, either at 24 degrees centigrade the relative humidity will be around 60%, or if you want to maintain the relative humidity, then the air will be on slightly higher temperature of 26 degrees centigrade, either here or here. If you are maintaining humidity 50%, then temperature will be higher. If you are maintaining temperature as 24 degrees centigrade, in that case humidity will be higher. So, in order to avoid this situation, sensible cooling is done. A sensible cooling of air is done from, let us say, from state 1 to state 2, and after sensible cooling, when we are on the wet bulb temperature line passing through this point, evaporative cooling can be done and we can attain this state, right. Suppose the relative humidity of outside temperature is 45 degrees centigrade, relative humidity is 10. So, if the outside temperature is 45, relative humidity is 10, you are somewhere here. So, now if you do the evaporative cooling right from this point, the humidity will be 70%, too high or more than 70%, 75% at 24 degrees centigrade. That may not be acceptable. Or if I want to maintain the humidity, in that case the dry bulb temperature will be around 29 degrees centigrade. 29 degrees centigrade temperature shall not provide the required comfort. So, in this case also sensible cooling shall be done up to this point. This is, let us say, 0.3 and this is 0.4. Sensible cooling will be done up to this point, up to this temperature 32.5 degrees centigrade. Here the sensible cooling was done 36 degrees centigrade, and then evaporative cooling shall be done. And arrangement for this type of climate will be, first of all, some dampers will be provided, right, then filters, after that cooling coil, and for evaporative cooling an air washer shall be provided. Air washer shall spray the water in air, and due to evaporation of water this cooling will take place. Now, here also we can consider the bypass factor in a similar fashion as we considered in the case of hot and humid environment. Now, after this we will take up single cooling coil and mixing process. Now, mixing is often done in air conditioning systems because Why mixing is done? Mixing is done in order to save energy. Now, fresh air is taken from outside, part of the fresh taken air is taken from outside, temperature of the fresh air is 42 degrees centigrade. The air which is leaving the room is at, let us say, 27 degrees centigrade. So, now cooling 27 degrees centigrade air is much easier, or I mean is less expensive than the cooling air at 42 degrees centigrade. So, here mixing of a steam comes into the picture. Outside air is at 42 degrees centigrade. Air which is leaving the room, let us say Tx is 27 degrees centigrade. So, if I want to cool this air, definitely I will be saving a lot of energy. But cooling from 42 to the required temperature and cooling from 27 to required temperature. But I cannot use this air 100%, because if I make 100% recirculation, the quality of air will reduce, oxygen content of air will reduce, carbon dioxide content will increase, and it is not advisable. So, part of this air is mixed with this, let us say 50-50, 50% of this, 50% of this. So, the average temperature will be, if I take 50-50 mixing, then 27 by 2, that is 69 by 2 is approximately 34.5. So, air entering the coil will not be at 42 degrees centigrade, it will be 34.5, and it shall be meeting the requirement of oxygen and diluted pollutants. So, this mixing is done basically in order to reduce the load on the plant. Now, we will take the mixing cases one by one. Now, the first mixing case is single coiling coil and mixing. Now, in this case, there is a cooling coil which cools the air, and this air goes to the room. There is a room, and after cooling in the room, after leaving the room, let us say this is which is going into the room, this is outside air, state 1. From state 1 it is entering the coil, leaving the coil at state 2, then entering the room at state 2 and leaving the room at let us say state 3. At state 3, part of the air leaving the room is mixed with 1 and we get state 4. And now this is state 4. The actual diagram is this mixture of state 3 and state 1 is entering the coil, getting cooled there, then it is going to the room, and the part of the air is vented outside and part of the air is again goes for recirculation. Now, if I want to depict this process on psychrometric diagram, now here suppose at 35 degrees centigrade, and let us take some example 35 degrees centigrade and 70% relative humidity, some coastal climate, right, and this air is mixed with the return air which is at let us say 26 degrees centigrade and 60% relative humidity. So, this is state 1 outside air and this is state 3 air which is leaving the room. Now, these two streams, air streams, they are mixed. If it is 50-50, the mixture will be at the exactly at the middle of this line. I am just taking the approximate position and that is going to be state 4. In this type of mixing, the mixing is done because geometrically we have to do it, or mathematically also we can do. Geometrically, suppose there is a pH diagram, there is a mixing from 1 to 3. this is 50-50. So, M1 by M3 is equal to, suppose this is A and this is B. So, M1 by M3 is going to be A by B in reciprocal. M1 by M3 is going to be A by B, length of this divided by length of this, or we can take in terms of dry bulb temperature also, difference in dry bulb temperature also. So, difference in dry bulb temperature between this point and this point is A, difference in dry bulb temperature between this point and this point here. We can take projection on y axis also, where the specific humidity is there, then again the difference in specific humidities can also be considered in order to find the ratio. So, once ratio is with us, we can easily locate the point 4 either with the help of temperature or with the help of specific humidity, or simply by taking the geometrical value through this reciprocal equation. Now, state 4 is attained. Now, after state 4, it passes to the room. Rest of the process remains same. Coil temperature, let us say it is 14. So, it will come here, and then coil temperature it will be. So, this is the next process, cooling and dehumidification. Cooling and dehumidification. If bypass factor is there, then instead of, you want to, so coil temperature has to be higher than this. So, suppose the coil temperature is 10 degrees centigrade, because if I take coil temperature 15 degrees centigrade, I may not be able to attain this position or this supply condition, this room condition. So, the temperature of the coil is less than this, approximately 10 degrees centigrade. It has some bypass factor also. So, instead of being supplying at 10 degrees centigrade, air may be supplied at, let us say here, at 13.5 degrees centigrade, and then heating can be done, and we will get the desired state. So, here I have missed the heater. So, one heater is also here. One heater is also here, because cooling and then heating. Cooling and then heating. And that is how we are getting the state of the supply air. Now, the last one is single cooling coil and bypass mixing. Now, here in this arrangement, after the cooling coil, mixing of this air can also take place. After the cooling coil, mixing of this air can also take place. So, part of this air, now there are 3 places, mixing is taking place at 3 places, 1 and 3, this is also 3, this is also 3, 1 and 3 here, and 3 and after cooling in the cooling coil, mixing is taking place. So, for such a situation, this is the return air. It is very simple to locate. This is our return air, this is our supply air. So, now mixing is taking place after the cooling coil between this point and this point, and we will get finally this point, maybe point 4. At point 4, the vapor will be, or sorry, the air will be entering the room. In actual practice, the temperature of supply air is not 24 degrees centigrade. For the sake of understanding only, I have taken temperature 24 degrees centigrade. Normally, temperature of the supply air ranges between 13 to 17 degrees centigrade. It is known as grill temperature. So, suppose in this room, I want to maintain certain temperature of 24 degrees centigrade. Room will have some sensible load and latent load, and temperature may be, let us say, 17 degrees centigrade. So, this or 15 degrees centigrade, we can take 15 degrees centigrade supply temperature, and then return air temperature may be at 25 degrees centigrade and 50% relative humidity, and this is the load line. The load line we will discuss later on. This is room load line, and this room load line we will discuss later on. I have assumed supply temperature 24 degrees centigrade for the sake of convenience and for the sake of convenience of understanding these processes. Likewise, we can have number of combination of the processes in order to attain the desired state of air in the room. But we must understand that whatever process we adopt, it should be energy efficient. We can come from this point to this point, we can come by other methods also, but those methods will be energy consuming. And therefore, this is the most convenient way of attaining this state. This is all for this lecture, and in the next lecture we will continue with the psychometric processes.